paper number 7. Question number 46. The number of water molecules in 1 liter of water is. When we talk about the water, the density of water is 1. Therefore, whatever is a liter of water is given, that corresponds to the gram. So when I talk about 1 liter, this 1 liter is equals to 1000 ml. That corresponds to 1000 gram. So molecular weight of the water is 18 gram. So when I'm talking about 18 gram of water, that corresponds to Avogadro's number of atoms. So 1000 gram, that will correspond to 1000 multiplied by Avogadro's number divided by 18. So that comes out to be 55.55 into Avogadro's number. Therefore option D. Question number 47. A sample of mixture of calcium chloride and NaCl, which is weighing 4.22 gram, on treatment to precipitate all the calcium as calcium carbonate, and this calcium carbonate is then heated quantitatively, converted into 0.959 gram of calcium oxide. We need to calculate the percentage of calcium chloride in a mixture. So this is a mixture which is being on treatment with the carbonate ions, definitely getting converted into calcium carbonate. If you calculate the molecular weight of calcium chloride, it is around 111 gram and calcium carbonate is 100. Now this calcium carbonate, they are saying further, is heated so as to convert it quantitatively into calcium oxide. So molecular weight of calcium carbonate is 100 and that of calcium oxide is 56. So when we can see the 100 grams of that 56 grams of this calcium carbonate, calcium oxide, is obtained from 100 grams of calcium carbonate. We have got 0.959 gram of calcium oxide, that will correspond to 0.959 multiplied by 100 divided by 56, that is equals to 1.79 gram. Now this 1.79 gram is obtained from certain amount of calcium chloride. So we'll calculate the weight of calcium chloride. So from this equation, 100 grams of calcium carbonate is obtained from 111 gram of calcium chloride. So 1.71 gram of calcium carbonate will be obtained from 1.71 multiplied by 111 divided by 100. So this comes out to be 1.89. So the total weight of calcium chloride in the mixture is 1.89, but we need to calculate the percentage of calcium chloride. So percentage of calcium chloride is a weight of calcium chloride, that is 1.89 divided by total weight of a sample 4.22 into 100. This answer comes out to be around 44.78. So that is around 45. Hence option C. Question number 48 is, which of the following is the Heisenberg's uncertainty principle? Heisenberg's uncertainty principle says that it is impossible to determine or certainly specify the location and the position of that position and the velocity of that particle. So momentum and P and the location, position, they are both are uncertain. So delta x into delta P is greater or equal to h upon 2 pi. Hence option A is correct. Question number 49. The lightest particle. First is helium, which is having around the mass which is 4 times the mass of the proton or the neutron. Proton and neutron, they are almost similar. The lightest one is a positron, which is similar to the electron. Therefore option B. Question number 50. The correct order of decreasing ionization enthalpy is. If we'll talk about this 4 element, we have a lithium belongs to group 1. Then we have a beryllium belongs to group 2. Then we have a group 13 boron and group 14 carbon. If you look at the electrons outermost shell configuration, this is 2s1, this is 2s2, this is 2s2 2p1 and this is 2s2 2p2. As per the periodicity trends left to right, the ionization enthalpy goes on increasing. When I talk about this, the lithium should be the lowest one, But in case of beryllium and boron, there is an exception because beryllium shows the most stable configuration. So that requires more energy than the boron. So the least one is lithium, then boron, then beryllium, and the last one is carbon. Therefore, our option is option B. Question number 51, the structure of ammonia is. When I talk about the ammonia, nitrogen, the number of hybrid orbitals, if we have to calculate for the nitrogen, that is equals to half into the valence shell of nitrogen contains the 5 electron plus the monovalent atoms are 3, so that is equals to 4. There are 4 hybrid orbitals, but there are 3 bonded atoms. That indicates there is one lone pair. The 4 hybrid orbital indicates the hybridization sp3. Generally that gives us the tetrahedral geometry, but due to the one lone pair, there is a distortion in the geometry and we get the geometry pyramidal geometry for this particular molecule. This is trigonal pyramidal structure, therefore option D. Question number 52, the compound X is the anhydride of sulfuric acid. So when I am talking about H2SO4, the anhydride, if I remove the water from this, the SO3 is left. Now in SO3, the 3 oxygen atoms are bonded to sulfur by the double bond. So we need to find a number of sigma and the pi bond. Every double bond is consisting of 1 sigma and 1 pi bond. Therefore, there are 3 sigma and 3 pi bonds. Therefore, option A. Question number 53. The Frankel defect is found in a crystal in which the radius ratio is. When I am talking about the Frankel defect where the radius ratio is generally low, there you will find the void space so that the ion can be missing from its original position and go in the void space. Therefore, option C. Question number 54. The heat of combustion of the substance. Generally for the heat of combustion, the energy generally found to be always negative. Therefore, option B, because these reactions are always exothermic in nature. Question number 55. The molar heat of vaporization of liquid is 6 kilojoule per mole. So delta H is given, vaporization, that is 6 kilojoule. I am converted into joule, 10 raised to 3 joule per mole. Entropy is given 16 joule per mole per Kelvin. I need to find the boiling point. So the temperature is equals to delta H upon delta S. So 6 into 10 raised to 3 divided by 16. That comes out to be 375 Kelvin. Option B. Question number 56. Formation of SO3 from SO2 and O2. So SO2 when reacts with O2, it gives us formation of SO3. Balancing of reaction, twice of SO2, twice of SO3. In this reaction mixture, if you will see, with the volume total 2 of sulfur dioxide and 1 of the oxygen. So 3 volume is changing to 2 volume. So during this reaction, volume is decreasing. So according to the Boyle's law, if the volume is decreases, the pressure should increase. So this reaction is favored by increase in pressure. Option A. Question number 57. Which is the best description of behavior of bromine in the following reaction? Now, if we'll talk about the bromine, left hand side, the oxidation state of bromine is 0. HBr, bromine is -1 and HOBr, bromine is +1. So in this case, one bromine is getting oxidized and one bromine is getting reduced. Hence, option B, both oxidized and reduced. Question number 58. Oxidation state of sulfur in sodium tetrathionate. We have a formula Na2S4O6. Let us assume the oxidation state of sulfur as X. Sodium is alkali metal, so that is +1. There are 2 alkali metals, so 2 into +1 plus sulfur, we have assumed it as X, so 4 into X, plus there are 6 oxygen multiplied by -2. This total comes out to be 0. Therefore, this is +2 plus 4x minus 12 is equals to 0. 4x minus 10 is equals to 0. So, x is equals to plus 2.5. Hence, option C. Question number 59. The hardness of water is estimated by. Generally, the hardness of water is estimated by EDTA method, because EDTA can form a stable complex and which can remove the hardness from the water. Question number 60, pick out the statement which are not true about the diagonal relationship between the lithium and magnesium. Polarizing power of the lithium and magnesiums are almost same. That is because the ionic radii after the removing certain number of electrons, that is +1 and +2, that becomes almost same. Like lithium, magnesium decomposes water very rapidly. This is absolutely wrong because it decomposes water but very slowly. Then lithium chloride and magnesium chloride are deliquescent. Yes, they are deliquescent. They are hygroscopic in nature. While like lithium, magnesium does not form the solid bicarbonate. Both these elements do not form the solid bicarbonate. Therefore, option B is the only wrong statement in this case. Therefore, correct answer is option C. The color of blue glass is due to. The blue glass is because of silicon oxide is generally mixed with the small amount of the cobalt oxide. Therefore, option B. 62, the red lead. Red lead is nothing but Pb3O4. This is basic, mixed, super or amphoteric oxide. This is generally called as mixed oxide because this is containing the Pb2+ and Pb+4 oxide. Generally, the mixed oxide term is used for those oxides in which the metal cation is present in more than one oxidation state. Hence, option B. Amongst the following, strong nucleophile is. Now, if you look at the first one, C2H5, over here, sulfur will be able to donate. Nucleophile is a nucleus loving, is the one which is having electron rich. So, sulfur can donate electrons since the electron donating group is attached to the sulfur. Over here we have a CH3, C double bond O minus. Now methyl shows the electron donating tendency. So somewhere because of the presence of this carbonyl group, this tendency has decreased. Then we have NH2. Compared to the nitrogen, the sulfur can donate this particular electron very easily. And then we have a cyanide group. Cyanide group shows the electron withdrawing tendency. Therefore, option A, which can act as the strongest nucleophile. Question number 64. The final product in the following sequence of reaction is. This is the alkyne CH. When on treatment with NaNH2, the acidic proton is replaced by the sodium. So we'll get CH triple bond C Na. This is on treatment with further CH3Br. Sodium will take the bromine and the sodium position will be taken by CH3. So we'll get CH triple bond C CH3. So we'll get the formation of propyne. Option B. Question number 65. Which compound does not give precipitate with ammonical silver nitrate? When I'm talking about ammonical silver nitrate, in this the silver will replace the acidic protons. Alkynes are generally acidic in nature. Only the terminal alkynes can give you this kind of reaction. If you see, these are the terminal where the terminal CH groups are acidic in nature. But whereas in this particular compound there is no terminal CH group. Therefore, this cannot give the precipitate with the ammonical silver nitrate. Question number 66. The gas released during the Bhopal tragedy was the methyl isocyanate gas. Question number 67. Which kind of defect is shown by the given crystals? If you look at the first layer, the all cations and anions as it is. Second layer, there is K plus missing, Cl minus missing. Third layer, there is K plus missing again. And in fourth case, the Cl minus. So equal number of cations and anions are missing from this particular crystal. Therefore, the defect which is shown by it is a Schottky defect. Option A. Question number 68. Which one of the following defect in the crystal lowers its density? Since in the Schottky defect, the cations are missing from its original position, so density decreases. Option B. Solution is prepared by dissolving 24.5 gram of NaOH in distilled water to give 1 liter of solution. The molarity of the solution we need to calculate. The molarity formula, the weight of the substance divided by its molecular weight into volume, that should be in liter. Weight of a substance which is taken is 24.5 gram. Molecular weight of the NaOH is 40 and that is dissolved in 1 liter of the solution. So when you calculate this, you'll get 0.6125 molar. Hence option B. Question number 70. The solubility of a gas increases in a liquid. The option is right, with the decrease in temperature, because when we talk about as the temperature decreases, the volume of gas is also decreases. It can be easily accommodated in the liquid. Can be generally seen in a sea water, where at the depth you can see there is a more dissolved oxygen, and because of that you'll get a better aquatic life at the depth of the sea rather than at the upper layer of the sea level. Question number 71. Which of the following reaction cannot abase for the electrochemical cell? The first one is H2O2 giving water. This is the redox reaction, and where the water will act like an electrophile. Water will act like an electrolyte. Option B, AgNO3 plus zinc. Here the AgNO3 solution will act like electrolyte, in which the zinc will be dipped. Option C, AgNO3 plus NaCl. These solutions will act like an electrolyte. But in option D, there is the KMnO4 acidified solution, which is carrying out the oxidation of FeSO4. There is no electrolyte in this reaction. Therefore, option D. Question number 72. The half-life of two samples are given and the respective concentrations are given to us. We need to find the order of reaction. From the half-life, we have an equation, half-life 1 upon half-life 2 is equals to initial concentration A2 upon A1 raised to n minus 1, where n is the order of reaction. They have given half-life for the first one is 0.1 upon 0.8, that's equals to 50 upon 400 raised to n minus 1. Therefore, 1 by 8 is equals to, this is also 1 by 8 raised to n minus 1. Both sides are same, therefore we can say n minus 1 is equals to 1. Therefore, n is equals to 2. So this is second order reaction. Question number 73. The rate of the reaction, that is rate is equals to K into RCl is given. Freezing point of the reaction is unaffected by the increasing temperature of the reaction. This won't be unaffected, it will get affected as you increase the temperature. Decreased on increasing the temperature of reaction. The freezing point is going to increase when the temperature of the reaction is also going to increase. Half of the reaction, reducing the concentration of the RCl to half. When I'm talking about, let's say if I'll do the concentration half, the rate of reaction will be original rate divided by 2. So definitely it will become half, as the concentration will become half. Therefore, option C. Question number 74. Which of the following is not property of the colloidal solution? Heterogeneity. Yes, colloidals are heterogeneous in nature. Particle size more than 100 mm. This is wrong. This particular case is for the suspension. Therefore, option B. Question number 75. The metal is refined by the Polymers process. This generally process used for the copper, as from the mixture of copper and copper oxide. To remove this copper oxide or to reduce this copper oxide, it is generally stirred with the green log of wood, that is in heated condition. So that is Polymers process can be used for the blister copper. Question number 76. The froth flotation process is based upon difference in the specific gravity of ore and the gangue particle. This is used when there is a hydraulic washing condition. Magnetic property, it's for the magnetic separation. Preferential weighting of the gangue particle by oil. Gangue particles are generally weighted by water, not by oil. Solubility of ore particle in the suitable reagent. Therefore, option D. Question number 77. Nitrogen dioxide does not dissolve in water. Dissolve in water giving nitric acid. Dissolve in water to give nitrous and nitric acid. Dissolve in water to give nitrous acid and to give off oxygen. NO2 when dissolved in water, it gives formation of HNO3 plus HNO2. So it gives the formation of both, that is nitric acid as well as nitrous acid. Therefore, option C. Question number 78. In the context of lanthanoids, which of the following statements are not correct? It is gradual decrease of the radii with the increasing atomic number. Left to right atomic radius decreases. This is correct statement. All members forms the +3 oxidation state. Yes, because they have 2 electrons in the 4s and 6s, and the 1 electron from the 4f orbital will be lost to give easily the +3 oxidation state. Because similar properties of the separation of the lanthanoid is not easy, definitely because their ionic sites are somewhere nearby. Availability of 4f electron result in the formation of the +4 oxidation state in all the members of series. This is absolutely wrong. Very few members can form the +4 oxidation state because +4 oxidation state formation requires more energy. Therefore, option D. Among scandium, titanium, palladium and the copper, the ions which are paramagnetic and diamagnetic. When I talk about scandium, it's argon 3d1 4s2, but when the +3 state is formed, the d orbitals will be and s orbitals 0. When I talk about the titanium in +4 state, again it will be 3d0 4s0. In palladium it will be 3d8 4s0. Therefore 3d8, that will be paramagnetic in nature. These are the diamagnetic. And finally copper argon, this is +2, this is also +2. Copper, 1 electron from the 4s will be lost, so 4s0 and 3d8 again. Therefore 3d9, this is also paramagnetic in nature. Therefore these two are paramagnetic and these two are diamagnetic. Hence option D. Question number 80. Which of the following is the thrioisomer? In the thrioisomer, two similar groups will be present on the opposite side. Here the two groups are present on the same side. Here the AA and DD, they are on opposite side. So this is a thrioisomer. Here also the D and A are on same side. So this is not a thrioisomer. So only 2 is a thrioisomer. Hence option B. Question number 81. Wurtz reaction involves the reduction of alkyl halide. In Wurtz reaction, generally we use sodium in ether, where the alkyl halides are converted into higher alkanes using sodium. Question number 82. Methanol on oxidation. Methanol on oxidation produces the acetic acid, formic acid containing 1 carbon, and that is further on treatment with ammonia, it will form the ammonium salt. Therefore option B. Question number 83. The end product of following reaction is isomer of alcohol. Isomer of alcohol is nothing but the ether. So we need to find a method which can give us the formation of ether. If you see the first one, this is B2H6 H2O2 formation. This will give us formation of alcohol. This is iodoform reaction with mercury followed by the hydrolysis and reduction. This also gives us formation of alcohol. C2H4 with the HI. This will give us double bond CH2. This is HI. This will give us formation of first alkyl halide. This is on further treatment with KOH. We'll get the formation of alcohol OH. And finally on treatment with concentrated H2SO4, we'll get the formation of corresponding ether. So we'll get formation of diethyl ether. So this is the method which gives us the formation of ether. Hence this is the correct option. Option C. When CH3COOH reacts with CH3MgX, CH3COH double bond OH on reaction with CH3MgX. This is highly polar which can donate a proton. So CH3 double bond O, the H replacement by MgX, and the proton will be accepted by the methyl group to create methane. So we get a formation of hydrocarbon. Hence option B. Question number 85. Acetonitrile on hydrolysis produces CH3C triple bond N. When on hydrolysis, this is negative and this is positive. Proton is positive, this is negative. So nitrogen will get the H and the carbon will get the OH. So CH3COH double bond NH, and this is undergoes the hydrolysis. H will be transferred, tautomerism, to get CH3C double bond O NH2. This is the first amide formation, but the further hydrolysis will give us the formation of acid plus ammonia. Hence the hydrolysis gives us the formation of acid. Option B. Question number 86. During diazotization of benzamine with the sodium nitrite and hydrochloric acid, Excess of hydrochloric acid is used primarily to check the hydrolysis of water, to ensure the stoichiometric amount of nitrous acid, to check the concentration of free aniline, and to neutralize the base from the during reaction. Excess of hydrochloric acid is generally used to check concentration of free aniline in the reaction mixture. When the glucose reacts with bromine water, in the glucose there is aldehyde group, there are two secondary alcoholic group and there is one primary alcoholic group. When it reacts with bromine water, only the aldehyde turns to COH while the other groups remains as it is. Therefore, this particular acid which we get, that is called as the gluconic acid, option D. Bakelite is elastomer, fiber, thermoplastic. It is a thermosetting polymer because it cannot be remolded in any other shape. 89. Polymer melamine is obtained by. It is obtained by the condensation polymer of melamine and formaldehyde. As it is, melamine structure, this is NH2 groups present over here, and it forms the formaldehyde by loss of condensation. Therefore, this particular polymer is a condensation polymer. Question number 90. Which of the following statement is not true about the drug barbital? It causes the addiction. It definitely causes the addiction. It is non-hypnotic. This is absolutely not correct because this is hypnotic reagent. It is tranquilizer, yes, and it is the sleeping pills. This all creates the hypnotic effect. Therefore, option B.